Imagine yourself standing on the edge of a vast, rumbling caldera, the ground beneath your feet vibrating with the raw power of the earth itself. The air is thick with the scent of sulfur, and in the distance, rivers of molten lava glow like veins of fire against the dark volcanic rock. This isn't just a scene from a blockbuster movie, it's the reality of our planet's dynamic inner workings. And right now, as of August 25th, 2025, we're witnessing an escalation in these forces that could reshape how we understand the interconnected systems of our world. From the fiery eruptions of Kilauea in Hawaii, to the explosive bursts on the sun's surface, and even to the seismic shakes rippling across the globe, there's a story unfolding that's as thrilling as it is profound. Stick with me through this deep dive, because by the end, you'll see how these phenomena might be linked in ways that challenge conventional science. And I'll reveal what could lie ahead for the rest of 2025 and beyond. We'll explore the latest data, bust some myths, and build a picture that's not just informative, but electrifying, encouraging you to ponder the bigger questions about our place in the cosmos. Let's start with the heart of the matter: volcanic activity, specifically the recent eruptions at Kilauea, one of the most active volcanoes on Earth. As of August 25th, 2025, Kilauea has just wrapped up its 31st eruptive episode in the ongoing Halemaumau eruption sequence, which ended abruptly on August 23rd after an intense 12.6 hours of continuous fountaining. This episode was no minor event. It featured lava fountains shooting skyward, creating a spectacle of glowing molten rock that lit up the night sky. According to the latest updates, this eruption demonstrated stronger radiative power compared to previous ones, signaling an uptick in the energy being released from deep within the Earth. Radiative power, for those unfamiliar, measures the thermal energy output from the lava and surrounding areas, and in this case, it surpassed episode 30 and earlier events, marking the highest recorded in this cycle. Why is this significant? Kilauea isn't an isolated hotspot. It's part of the Hawaiian volcanic chain, fueled by a massive mantle plume that punches through the Pacific Plate, the largest tectonic plate on our planet. This plume acts like a conveyor belt of superheated material from the Earth's core mantle boundary, rising thousands of kilometers to the surface and manifesting as lava flows, ash plumes, and seismic tremors. To truly appreciate the impact, consider the broader context of global volcanic trends in 2024 to 2025. Reports indicate that as of early August 2025, 46 volcanoes worldwide were in a state of continuing eruption, a figure that reflects a steady hum of activity, but with notable spikes in intensity. From Iceland's Reykjanes Peninsula, where lava fields have been expanding since late 2024, to Indonesia's Mount Merapi, which has seen increased pyroclastic flows, the planet seems to be in a phase of heightened restlessness. In Hawaii alone, Kilauea's activity has been episodic but escalating, with ground deformation data from the past 24 hours indicating rapid inflation at the summit following days of deflation, a classic precursor to potential future eruptions. This inflation suggests magma is accumulating beneath the surface, building pressure like a pot about to boil over. Imagine the immense forces at play, temperatures exceeding 1,000 degrees Celsius, pressures that could crush diamonds, and chemical reactions releasing gases that propel lava hundreds of feet into the air. These eruptions don't just reshape landscapes, they inject aerosols into the atmosphere, potentially influencing global weather patterns by reflecting sunlight and cooling temperatures slightly, as seen after major events like the 2022 Hunga Tonga Hunga Ha'apai eruption. But what if this volcanic surge is part of a larger energetic upwelling? Data shows that volcanic emissions, including sulfur dioxide, hit record highs in certain regions in 2024, with Canlaon volcano in the Philippines releasing 6,700 metric tons in one event alone. Extending into 2025, we've seen similar trends, with 47 volcanoes erupting globally as of mid-January, up from previous weeks. This isn't random, it points to increased convection in the mantle, where hotter material rises and cooler sinks, driving plate tectonics and volcanism. As we delve deeper, you'll see how this ties into solar influences and seismic events, creating a web of interactions that could explain why our planet feels more alive than ever. Hang in there. This is just the beginning, and the connections will blow your mind. Shifting our gaze upward, let's talk about the sun, our ultimate energy source, which is currently in the throes of solar cycle 25. As of August 2025, we've passed the solar maximum, which peaked higher than initially predicted. Early forecasts pegged the maximum at around 115 sunspots in July 2025, but actual observations show a 13-month smoothed monthly value reaching 156.7 in August 2024, indicating a stronger cycle than solar cycle 24. We're now in the descending phase, with sunspot numbers beginning to decline, but activity remains elevated. Predictions placed a maximum between 138 and 161, sometime between May and October 2024, aligning with the observed peak. What does this mean? During solar maximum, the sun's magnetic field flips, leading to increased sunspots, dark, cooler regions on the surface that are hotbeds for flares and coronal mass ejections, CMES. These events hurl billions of tons of plasma into space at speeds up to 2,000 kilometers per second, bathing Earth in enhanced radiation. Shifting our gaze upward, let's talk about the sun, our ultimate energy source, which is currently in the throes of solar cycle 25. As of August 2025, we've passed the solar maximum, which peaked higher than initially predicted. Early forecasts pegged the maximum at around 115 sunspots in July 2025, but actual observations show a 13-month smoothed monthly value reaching 156.7 in August 2024, indicating a stronger cycle than solar cycle 24. We're now in the descending phase, with sunspot numbers beginning to decline, but activity remains elevated. Predictions placed a maximum between 138 and 161, sometime between May and October 2024, aligning with the observed peak. What does this mean? During solar maximum, the sun's magnetic field flips, leading to increased sunspots, dark, cooler regions on the surface that are hotbeds for flares and coronal mass ejections, CMES. These events hurl billions of tons of plasma into space at speeds up to 2,000 kilometers per second, bathing Earth in enhanced radiation. Right now, solar flux measures, like radio flux at 10.7 centimeters wavelength, X-ray flux, and extreme ultraviolet radiation, are still above average, though trending downward. A strong solar flare peaked on February 23, 2025, a reminder that even in decline, the sun can pack a punch. In recent weeks, large sunspot groups have rotated into view, some on the Earth-facing side, potentially triggering geomagnetic storms. For instance, proton flux has been elevated following a massive far-side CME earlier this month, demonstrating the sun's ability to influence our planet even from its hidden side. Picture the sun as a colossal fusion reactor, 1.3 million times Earth's volume, where hydrogen atoms smash together at 15 million degrees Celsius, releasing energy that travels 150 million kilometers to us in just 8 minutes. This energy not only powers life, but can disrupt satellites, power grids, and even, as some research suggests, influence terrestrial geology. The descending phase of solar cycle 25 is expected to continue until solar minimum around 2030 to 2031. But the next few years could still see bursts of activity, especially with lingering high flux levels. Why should you care? These solar events create auroras, but they also pose risks. Think of the 1859 Carrington event, which fried telegraphs. Today, a similar storm could cost trillions in damages. As we connect the dots later, you'll discover how this solar upsurge might be syncing with Earth's internal energies, amplifying volcanic and seismic activity in ways that keep scientists debating. Keep reading. The puzzle pieces are falling into place. Now, Let's ground this discussion, literally, with earthquakes, the sudden releases of stress along fault lines that can topple cities and trigger tsunamis. As of August 25th, 2025, the world has seen a flurry of significant quakes. Just today, a magnitude 6.1 struck east of the Kuril Islands, followed by aftershocks in the region. Yesterday, a magnitude 6.0 hit off the Pacific coast of El Salvador and Guatemala, centered 81 kilometers southwest. Looking back, lists show a magnitude 7 plus event 193 kilometers northwest of Abapura, Indonesia, on August 12th, and earlier, a staggering magnitude 8.8 megaquake rocked the Kamchatka Peninsula on July 30th, the third largest this century. Interestingly, this Kamchatka event has an intriguing geographic counterpart. Recent activity in the Drake Passage, including a magnitude 4.8 on August 23rd, though not as strong as past events. Earlier in 2025, a magnitude 7.4 shook the Drake Passage in May, creating a pattern that some observers liken to a ping-pong effect across antipodal points, regions directly opposite each other through Earth's core. Antipodal connections aren't just coincidence. Seismic waves from a major quake can focus energy on the opposite side, potentially triggering events there. Kamchatka and the southern tip of South America are nearly antipodal, and the timing, Kamchatka in July, followed by southern tremors, suggests energy transfer. Globally, reports highlight significant quakes in the last 60 days, including a magnitude 6.5 in Turkey on August 10th and others in the Pacific Ring of Fire. With solar cycle 25's activity, some studies hint at correlations, links between solar activity and large earthquakes, possibly via electromagnetic influences on the ionosphere affecting crustal stress. Emerging research on solar heat affecting seismic activity challenges traditional views. Envision Earth's crust as a brittle shell over a churning interior. External energies from the sun could tip the balance, like a final straw on a loaded camel. As we approach the interstellar wildcard, these patterns gain intrigue. Don't stop now, the climax is coming. Antipodal connections aren't just coincidence. Seismic waves from a major quake can focus energy on the opposite side, potentially triggering events there. Kamchatka and the southern tip of South America are nearly antipodal, and the timing, Kamchatka in July, followed by southern tremors, suggests energy transfer. Globally, reports highlight significant quakes in the last 60 days, including a magnitude 6.5 in Turkey on August 10th and others in the Pacific Ring of Fire. With solar cycle 25's activity, some studies hint at correlations, links between solar activity and large earthquakes, possibly via electromagnetic influences on the ionosphere affecting crustal stress. Emerging research on solar heat affecting seismic activity challenges traditional views. Envision Earth's crust as a brittle shell over a churning interior. External energies from the sun could tip the balance, like a final straw on a loaded camel. As we approach the interstellar wildcard, these patterns gain intrigue. Don't stop now, the climax is coming. Enter the disruptor, 3I/ATLAS, the third confirmed interstellar object zipping through our solar system, discovered on July 1st, 2025, by a NASA-funded telescope in Chile. This comet, following Oumuamua 2017 and 2I/Borisov 2019, is barreling in from beyond at incredible speeds, currently around 58 kilometers per second, accelerating to 68 kilometers per second at perihelion. Its coma, a plasma dusty envelope, spans twice Earth's diameter, making it the largest interstellar visitor observed. Unlike typical comets, it's on a hyperbolic trajectory, unbound by the sun's gravity, destined to exit after its close solar approach. As of now, 3I/ATLAS is heading toward the sun, with images revealing a bizarre tail and dynamic structure. Its path includes a close Mars flyby in late September or early October 2025, optimal geometry with inner planets around October 21st to 22nd, perihelion a week later, and a Jupiter encounter outbound. This trajectory positions it to interact electromagnetically with the solar system. Speculatively, its arrival coincides with recent solar upticks, flares aligning with its position relative to Mars. Drawing from Oumuamua's 2017 flyby, which saw X-class flares and a magnitude 8.2 Mexico quake near perihelion, 3I/ATLAS could similarly perturb. How? In an electric universe framework, the solar system functions as a circuit, with currents spiraling along the ecliptic. An interstellar object like this, highly conductive and plasmified, could short-circuit flows, enhancing energy to sunspots and triggering flares or CMEs. As it nears, heating ionizes volatiles, boosting its electromagnetic influence. While mainstream views see no direct effects, the timing with Kamchatka's quake and solar flares invites hypothesis. Eclipse season adds drama. A lunar eclipse next full moon, solar eclipse near equinox, then 3I/ATLAS-Mars conjunction October 1st. Tying it all, volcanic surges, solar max, quakes, and this intruder suggests systemic upsurge. Mantle plumes fuel volcanoes like Kilauea, solar radiation penetrates, heating crust. Geomagnetic storms correlate with quakes. Interstellar disruptions amplify. For 2025 to 2026, expect continued activity. More eruptions, flares, shakes. This narrative isn't alarmist, but a call to wonder at our vibrant world. We've journeyed from lava flows to cosmic visitors, revealing interconnections. What will 3I/ATLAS bring? Stay tuned to the skies. The show's just starting. As we consider the broader implications of these escalating natural forces, it's impossible to ignore how they might intertwine with global climate patterns, potentially ushering in unpredictable shifts that affect every corner of our lives. Picture vast plumes of volcanic ash and gases soaring into the stratosphere, where they linger for months or even years, scattering sunlight and subtly altering temperature gradients across oceans and continents. This could intensify weather extremes, from prolonged droughts in already arid regions to heavier monsoons that flood coastal communities, creating a ripple effect on agriculture, water supplies, and ecosystems. With the sun's heightened activity adding extra heat and radiation to the mix, we're looking at a perfect storm where solar-induced atmospheric changes amplify volcanic cooling effects, leading to volatile swings in weather that challenge our predictive models and force us to adapt in real time. The thrill lies in the uncertainty. What if this convergence sparks a new era of climate resilience, pushing humanity to innovate sustainable solutions that harmonize with these powerful cycles? Delving deeper into the technological realm, the surge in solar activity poses both risks and opportunities that could redefine our reliance on modern infrastructure, keeping us on the edge of our seats as we navigate potential disruptions. Envision a massive coronal mass ejection slamming into Earth's magnetic field, inducing currents that overload power grids and fry transformers, plunging cities into darkness much like smaller events have done in the past. Satellites could glitch, disrupting GPS navigation, financial transactions, and even airline communications, while radiation storms threaten astronauts and high-altitude flights with unprecedented exposure. Yet, amid these challenges, there's an exhilarating potential for advancement. Heightened solar flux could inspire breakthroughs in space weather forecasting, leading to smarter grid designs and shielded electronics that make our tech ecosystems more robust. As 3I/ATLAS streaks through, its electromagnetic perturbations might accelerate these innovations, turning what could be chaos into a catalyst for engineering marvels that safeguard our connected world. Beyond the immediate earthly impacts, the arrival of an interstellar wanderer like 3I/ATLAS opens a gateway to profound scientific discoveries, inviting us to question the origins of our solar system and the vast tapestry of the universe itself. Imagine astronomers peering through advanced telescopes as this object sheds layers of ancient ice and dust, revealing chemical signatures from distant star systems that could rewrite our understanding of how comets form and carry the building blocks of life. Its rapid transit might expose rare isotopes or exotic materials, offering clues about interstellar medium dynamics and even hinting at processes that seeded planets with water and organics billions of years ago. The close flybys with Mars and Jupiter provide unique observational windows, potentially capturing gravitational interactions that test relativity theories or uncover hidden resonances in planetary orbits. This cosmic visitor isn't just a spectacle, it's a time capsule hurtling through space, promising revelations that could ignite a new golden age of exploration and deepen our sense of wonder about the infinite possibilities beyond our celestial neighborhood. Finally, as these cosmic and terrestrial dramas unfold, it's a powerful reminder to stay vigilant and engaged, transforming passive observation into active preparation that empowers us all to thrive amid the unknown. Think about how monitoring apps, community networks, and personal readiness kits could turn potential hazards into manageable adventures, fostering a global sense of unity as we share data and stories in real time. Whether it's learning basic earthquake drills, investing in solar-powered backups, or simply gazing at the night sky with renewed curiosity, each step we take builds resilience and connection. The energy surging through Earth and the heavens isn't a threat. It's an invitation to evolve, to embrace the rhythm of the universe with open hearts and minds. So, as we watch the lava flow, the sun flare, and the stars align, let's commit to this journey together, knowing that the greatest discoveries often emerge from the most dynamic moments. What secrets will you uncover next? As we stand at this crossroads of geological upheaval, solar spectacle, and interstellar intrigue, the unfolding events beckon us to become active participants in a grand cosmic narrative, sparking a shared sense of curiosity that could unite us across borders and generations. Imagine communities worldwide tuning into real-time seismic alerts, solar flare warnings, or telescope feeds tracking 3I/ATLAS, transforming raw data into stories that inspire awe and collaboration. Schools could launch projects analyzing volcanic ash for climate clues, while citizen scientists map earthquake patterns, contributing to global databases that sharpen our predictions. This isn't just about surviving nature's intensity, it's about thriving through it, channeling the planet's energy into a movement of discovery and innovation. What if the next big breakthrough in understanding Earth's rhythms comes from a collective effort fueled by your curiosity and passion? The universe is calling. Will you answer by diving deeper, sharing knowledge, and embracing the wonder of our ever-changing world?